So we'll start again. So Common Core is G for geometry, CO for congruence, and it's number 9, and it is proving theorems for lines and angles. Okay. This makes Mr. Daly very happy that I put down the Common Core every day. Okay. I understand you guys are like, oh, okay, whatever, right? So, but we will do that. So anyway, take a look at this first example, okay? Now, if this is a right angle, this 5, common sense, this side here must be longer than the 5. You agree? Has to be. If it were the same side, if this side were the exact same side as 5, you wouldn't have a triangle, right? So for sure, I know that this side's got at least. So if x were 2, it wouldn't work. It would not work if x were 2. That would make them equal. If they were equal, you wouldn't have a triangle. It's got to be bigger than 2. If it was 3, 4, 5, it would make a triangle. So let's take that whole idea and say, okay, well, this side absolutely must be, so the x plus 3 must be greater than 5. Not equal to, but greater than, right? It's got to be bigger. It can't be equal. If it's equal, then you've got the same side, same length. It's not a triangle, okay? So we set up our inequality. So first one says right and inequality, okay? I just did that. Now the second part is let's just solve it. So if we want to solve this inequality, we'll go minus 3. We'll have x is greater than 2. Greater than. So it could be 2.1. It'd be a really small, skinny triangle, but it could be 2.1. It wouldn't be a very good triangle, but it has to be bigger than 2 for this triangle to exist. Does that make sense? Okay. All right, example 2. Write and solve an inequality for this figure. Okay, so obviously this side, the hypotenuse, has got to be larger than the leg, right? So we'll go straight to 2x minus 5 has to be greater than x. So, okay, what are all the possible values of x? We've written our inequality. So as we solve for x, we'll find out what all the possible values of x can be for this triangle to exist. So go minus x, I'll have a 1x minus 5 is greater than 0. Okay. Plus 5, I'll have an x is greater than 5. Okay. So if x are greater than 5, well, let's check it out. Let me put those numbers in just for fun. Let's see. Let's put in 6 just for fun. If this is 6 and this is 6, we have 12 minus 5. 12 minus 5 is 7, and obviously the side 7 is going to be bigger than 6, right? So it does. To me, it makes sense. I'm hoping it makes sense to you guys. Okay. All right. Easy so far? Yeah. Okay. Slide it up. I will challenge you guys someday when you're in pre-calculus, okay? You guys are the smart ones. Someday I'll challenge you. It's coming. All right. Example 3. Find the value of x and y. Okay, so when I take a look at this, I see the parallel lines, right? So with the parallel lines, I know that these angles must be equal. Now, I learned this thing earlier about this converse. I think it's in our reading. We've got this converse transversal, which means if the lines are parallel, if it's 90 here, it's 90 there, right? I just read that. So let me put in a little 90-degree angle here. So the first thing I'm going to do is know that the 2x has to equal 90, right? So I'm going to go right there. Start with 2x equals 90. That angle's got to be 90 degrees, which makes finding x pretty easy, right? So then x is equal to 45 degrees. Just divide by 2, divide by 2. Okay, now if x is 45, let's find y. Well, the same thing. I know that 3y minus 2x. I know that this angle is also equal to 90, right? So I know that my 3y minus my 2x equals 90. But I know what x is, right? X is 45, so I put it in my 45 for x. So I can go, all right, 3y minus 2 times 45 equals 90. That's 90. 2 times 45 is 90, so I got a 3y minus 90 equals 90, right? Add 90, I get 180. 3y equals 180 because I went plus 90 plus 90. Divide by 3, y is 60. How's that? That wasn't so bad either. Right? Ready for me to turn the page? Okay. And a proof. Oh, hate proofs, don't you? We can do it though, okay? So let's take a look at what we have. AD is perpendicular to BC. Okay, and that's already marked for us, right? That helps. AD is perpendicular to AB. Okay, I've got that marked also. And BC is perpendicular to DC. So I've got that is already marked too. Okay, so step one, obviously step one has got to be the given, right? So step one is all of this. We'll squeeze it in the best we can. We'll go, okay, AD parallel to BC, AD perpendicular to AB, and I'll squeeze in the BC perpendicular to DC. Okay, obviously given. Okay, so write that down and then let's make a plan. Let's see what we have. Okay, what I want to prove is these two lines are parallel. These are parallel. I want to prove these two. Okay, so here's what I know. Okay, this one's just a matter of going perpendicular, 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 perpendicular. Okay, I'll show it again. Perpendicular, 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 perpendicular. Okay, that's what I'm going to do. So I'm going to move from here to here, and then from here to here. Okay, so we just learned, we had this theorem about this perpendicular transversal. We just read it. Okay, perpendicular transversal says if two lines are parallel and the transversal is perpendicular here, it's got to be perpendicular here, right? So right off the bat we say AD perpendicular to DC. Okay, and the reason for that is, so let's mark that. That is our perpendicular transversal theorem. You do not have to memorize the names of these. If you want to write out what it says, that's fine. I will abbreviate, but you just have to say something that makes sense. Okay, in this case, because they're parallel here, they've got to be perpendicular there. Okay. And the last thing is they're going to say if indeed they are perpendicular, 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 right? It's going to force the lines to be parallel. Okay, perpendicular, perpendicular. It's going to force the lines to be parallel. So, and that's by our converse perpendicular transversal theorem. Okay. Yeah, it's also perpendicular, isn't it? Yeah, and once you get this perpendicular and these two perpendicular, they're all perpendicular, aren't they? All the way through. What's that, Keisha?
To abbreviate the perpendicular is
right.
PTT.
I would not know that. Okay, if you put down PTT, I'd probably come and say, what are you trying to say here? And you could tell me and I'd say, okay, right? If I were on a test and I was grading a test, Keisha, I probably would not figure that out. But I like the PO though. The PO is my favorite one. That's something I'm gonna use from here on out. The PO, property of equality. Okay, so there's our homework. 1 to 15 odd, 40, 41, 42. And that's all I have today. So